Okay, hello everyone. My name is Matthias Schäfer. I'm glad to speak here today. So I will talk about JavaScript application architecture with Backbone.js. And before I would like to start, I'd like to ask who of you knows Backbone.js by name? Okay. And who of you has worked with it, done some coding? Okay, good. I will talk about similar topics as Stefan did. So my name is Matthias Schäfer, as I said. On the web I'm known as Mollily. I'm a software developer at 9 Elements, which is a company mostly doing web applications with Rails and JavaScript, and also some Flash and interaction design, iOS development. So software development is what we do. Yeah, first of all, I would like to categorize the JavaScript use cases in 3 categories. So first of all, there are the simple JavaScripts, unobtrusive JavaScript. So that means JavaScript is just used for progressive enhancement. And the second category are JavaScript-driven interfaces, which rely heavily on JavaScript, like Facebook, for example. They do much of Ajax, the interface is severely driven by JavaScript, but these type may be backwards compatible. So these interfaces can work without JavaScript. And the third category are the single-page application, which rely totally on JavaScript. So without JavaScript, they will not work. These are desktop application, desktop class applications, like for example Gmail. And today I will mostly talk about single-page applications, which does mean there are good libraries which will help you in the other categories, but I will mostly focus on this part today. So if you want to develop a JavaScript application, there are a couple of questions you have to ask, and you have to find an answer for that. For example, you will need some kind of library, some kind of code which does the DOM scripting for you, and mostly you will use a kind of model view binding library, like for example Angular.js, and most of the time you will do some HTML templating. We have seen this before. And for general JavaScript programming, you will need some helpers. And last but not least, you will need to package your code and ship it and send it to the client. So you will need several helpers and tools. And you have plenty of options. Some of these options are full stack solutions. So they are opinionated. They give you an answer to every of these questions. They have built-in tools for that. So there are some minimal libraries, like for example Backbone and Spine, and Knockout and Angular. It's a step further, and JavaScript MVC provides also several tools. It's a framework, full stack solution, and of course there are Dojo and YUI, and even bigger frameworks are Sprout Core, XJS, or Cooksdo. And if you don't want to write JavaScript at all, you might also build your applications in Google Web Toolkit or Cappuccino, for example. So today I won't talk about the full stack frameworks and the solutions which deal with all questions. Today I will talk about a very minimal and small library, which is Backbone. So Backbone is at the beginning of that. So this is kind of these solutions are they provide an answer to every of these questions. So in general, as you saw, there are so many libraries you can choose from. So there is no golden path in JavaScript application development. There are only few conventions and standards, and for example, the MVC pattern is quite important in most of these libraries I named. But the problem is every one of this library has its own interpretation of the MVC pattern, for example. And most of these libraries seem to reinvent the wheel. So if you choose, for example, one application stack like a Google Web Toolkit, you won't, you're trapped, and you cannot just switch to another library or take a module out of, say, the Backbone world. So these are the general problems in application development. And so today I will focus on a very small part, which is very open because it's not a whole framework. It's just a single topic solution. Yeah, and this is called Backbone. Backbone.js is a simple small library. It's the core of it is just, I think, 600 lines of code, and altogether it's I think 1,300 lines of code at the moment. It has one strength and one main topic, and this is separate business logic from interface logic. I will talk about what that means in particular. So Backbone is a very popular library. Huge IT companies are using it, like, for example, Groupon and SoundCloud and so on, for desktop and mobile apps. It's quite stable. It has almost reached 1.0, and it's actively developed, and of course it's free and open source, so it's driven by a very vibrant community. Before I explain the different parts of Backbone, there are some dependencies. So of course Backbone needs some kind of DOM library. For example, normally this is jQuery, but you can also choose Zepto, for example, on mobile, or in theory you could use libraries like Ender, which is I think Bonzo. So you might choose the DOM scripting and Ajax library you would like to use, but most of the time most Backbone applications use either jQuery or Zepto. Underscore is a library which is from the same authors. It's a utility belt. If you're familiar with ECMAScript 5, most of the functions from ECMAScript, the new array and string and so on methods, they are present in underscore. So it's a general helper for functional and object-oriented programming. It's also it's a small library which you can use every day. It has helpers like for dealing with lists, for example. And most of the time you will need to choose one of the existing templating engines. So you can use, for example, the templating function from underscore, or you might pick Moustache or Handlebars.js. So Backbone is very open in which library you choose there, so you can choose your favorite templating engine.
I also recommend the Baba.js template engine.
Sorry, how?
Another cool template engine called Baba.js.
Baba.js?
Yeah.
Ah, okay. Okay, thank you.
But it's still good.
Now I will talk about the parts of Backbone in short. There are just these 6 classes in Backbone, and they are, as I said, very lean. So you have the events, models and collections, the view class, and as an addition, history and router. So I will start with events, which is basically the core functionality of Backbone is in this mix-in. It's a mix-in which allows you to dispatch events and listen for events. So you have 3 methods, like you have in jQuery, for example. You have the on method, the off method, and trigger. With on you can register callbacks. With off you can deregister them, and with trigger you can trigger an event. So this is the key feature of Backbone, which is included in all the other classes. So this event-driven approach is basically the most important feature of Backbone, as we will see in a minute. Yeah, the model is like in the MVC controller pattern. MVC pattern, like in the MVC pattern. The model is the place where you store your raw data. And of course, the business logic, which means if you manipulate the model directly, you can do it in a method of your model. The key feature of the model is the attributes hash, which is the actual object where the data is stored. And the interesting part is if you change the data, like we have seen it on AngularJS, there are change events which are triggered whenever you change the attributes of a model. So this is the raw data place. And of course, you can retrieve model data from your server and save them back to the server. And most of the time, this is done with RESTful HTTP. So you get your model, for example, via JSON. So JSON is the normal, the standard format which Backbone is using. And of course, you can impose some validation constraints, like you know it, for example, from a server-side MVC framework like Rails. This is an example for a simple model. We create a new model by saying model.extend, and in the extend call you could also declare new methods, so which the normal model doesn't have. So in this case, we are not doing this. We just take the normal model methods and properties. So we have a car class created, and in the second line we create an instance of this class using the standard new operator from JavaScript. So car is basically a constructor method, and we pass some data to the model. So we fill the model with data. In this case, it's very easy. We just pass an object with a name property and say DeLorean DMC12. And then, for example, here we can get the name. We cannot say car.name, but we have to say car.get, because this is the way how Backbone allows you to access the attributes of the model. So car.get.name would alert DeLorean DMC and so on. So, a collection is another class of Backbone, which is basically a list of models. And the key point there is you can modify the list, like you can do it with a normal JavaScript array. And the interesting part is that this is also an event emitter, and it triggers add, remove, and reset events. And with this events, you can, for example, react upon changes of the list in your view. And of course, it implements a couple of list helpers like map, reduce, sort, and filter you all you need to deal with lists of models. So yeah, the counterpart of the models and collections are the views. So I will probably, a view technically, I will put it technically first. So a view normally owns a DOM element, so it governs a part of your DOM. It knows about the model and collection, so it has a link to the model and might get data from it or set data. It handles DOM events, so for example, if you have a form collection, if you have a form, you can get the data the user has entered and, for example, save it to the model. And you might also, to set up model view binding, you might observe model events, like mostly change events, and react upon that. And I think the interesting part of a view is that in Backbone you normally render a view, which means if you call the render method, the visual representation, the HTML representation, is created in the DOM. So you create a representation of your model data in the DOM, so the user can interact with it. This is called the render pattern. So a view has a render method, which mostly looks like this. For example, you, of course, you will not repeat this code over and over again. It works like this. You have some model attributes like foo, hello world, and then you have some kind of templating. In this case, it's mustache, handlebars, style. You could use other templating languages, of course. So this would be the template. You might use any templating engine which allows you to specify some kind of function you can call passing parameters, and then HTML is created. So in this example, the output of the templating engine would be p hello world, which means the foo attribute is inserted here, and this would be then the HTML which should be displayed, and you just say, for example, you use the HTML method of jQuery to, so this would be, the return value of this is hello world, and so basically the user would see p hello world if this is rendered. So this is an example with our car. It doesn't use I'm not using a templating engine here, so it's more simpler and easier to understand. I just here's the render methods. In the render method, I I just set HTML with the HTML method. I say name, and then I get the name of the model. So, and then I create a car, one of these car views. Pass the model car which we have created to the view, so the view knows about its model, and then say, please use this element. This is of course jQuery syntax. Use this element to render the view, and then I say render, and what I would see is name is, I think, what was this, DeLorean DMC12. Yeah, that. Do you have a question? No. So Stefan told us about a model view binding in Backbone. In plain vanilla Backbone, you don't have. I wanted to explain that. Yeah, of course. In this case, we have set up a model view binding, which means the view is listening to change events on the model. This is done in the initialized method. We say model.on change, and in case the name of the model changes, the view in this case just renders itself afresh. so the name is updated. So this is a very, very basic example. Of course, in real life, you won't you don't need to render the whole view. If the model changes, you can set up the binding more precisely. So basically, I want to say you have to set up model view binding yourself. There's no automatic mechanism in Backbone. Yeah, I will skip the rest of this because, yeah. The last part of Backbone are the router and the history. The router is one of the parts which allows you to make single-page applications, because the router maps URLs of your website to a specific JavaScript code, which means you have, for example, an URL /article/ and then the name of the article. You can route this to a specific code in your application and then to show the article which the user wants to read. And yeah, you cannot just react upon URL changes. You can also set the URL while you're in your single-page JavaScript application, and this is either done using HTML5 history, which is push state and pop state and so on. This is the default, I think, and there's a fallback for older Internet Explorers or recent Internet Explorers and other browsers which do not yet support history. This is the hash URL approach, which you might know from Twitter, for example. Twitter is also the twitter.com web interface is also a single-page application. They're using the hash URL approach. So, but they will, I think, switch to the HTML5 history approach in the future. So yeah, that's one of the cornerstones of Backbone to create single-page applications. Yeah, so I think this is an overview how it could look like if you create a web application with Backbone. So yeah, on the server, in most cases, you have the database, and you fill your models and collections with data from the server, for example. Then you have some kind of views which observe the models and render the models. So the view create the DOM interface, the HTML, CSS interface. Most of the time they are using some kind of templating engine to create HTML5, which is then appended to the DOM. And yeah, the view might also, as I said, every view governs a DOM element, and you can use the whole jQuery power, for example, to work on the DOM, which is associated with one view. So I have to. Oops. Okay. So yeah, what I told you so far is basically everything that Backbone provides. The summary on the Backbone.js homepage, backbone.js.org, I think. It says Backbone gives structure to web applications by providing models with key value binding and custom events, collections with a rich API of innumerable functions, views for declarative event handling, like I showed you, and connects it all to your existing API over a REST for JSON interface. Yeah, that's a quite good summary of what Backbone is about, and I would add routing. So routing is mentioned here, I think. As I said, Backbone is very minimal, and that is all. So these are all the features of Backbone in a nutshell. So which leads to the topic I want to talk about today, which is application structure on top of Backbone. So with Backbone alone, you cannot create an application. It provides some core models, some core patterns for your application, but if you build a real large application on top of Backbone, you need a proper architecture. So yeah, I have to lower some expectations about Backbone. It's very minimal by design, and yeah, that's by intent. So the makers of Backbone doesn't want it to be a full-fledged framework. They do not want it to have automatic model view binding and so on and so on. So the philosophy of Backbone is there's more than one way to do it, like the Perl motto, I think. So it's not like Google Web Toolkit, which has a convention for everything. In Backbone, you're very free to choose your own approaches, and yeah, so Backbone does not provide a structure to how to structure your application on a top level. And in contrast to other frameworks like AngularJS, it's not really MVC. This topic is very disputed, so I would say it's not MVC, not classic MVC like you can read it in a CS book, for example, and it's not MVP and not MVVM like other frameworks. So yeah, Backbone is not a classic approach to application design, I would say. So you have to bear that in mind when you work with Backbone, I think. So what can we do about that? First of all, I would like you to show some comments. So someone wrote on Hacker News, sorry. I'm trying to learn Backbone, I really am, but there are so many tutorials suggesting everything. I don't have a clue about how to structure my project. And yeah, every step I take with Backbone feels like a misstep because it seems like there's no right answer by design. So I'm paralyzed. Yeah, that's the question for us today. What to do? I would say he or she is right in the saying there's no right answer by design. That's right. Backbone doesn't have a right answer by design. That's by intent. So what can we do about that? First of all, what is an application? So what requirements does a JavaScript application have? Most of the time an application has numerous screens, so I don't have one screen, but I have several screens, several views, and there might be a transition between them, so either visually or semantically I have some kind of transition between them. Of course, a screen typically consists of multiple views. For example, I have different panes in a screen which interact with each other. So these views mostly correspond to some modules which have to communicate with each other. And of course, we're in the web and we're using different APIs, mostly our own APIs on the server, but also different web services or widgets from third-party companies. Yeah. So most of the data is loaded asynchronously. And so my conclusion is, Stefan talked about these examples, these to-do list examples. So as said, Eddie Osmani has compiled a repository of to-do list examples in basically all existing MVC style frameworks, and I would say these examples are of course they are very good for you if you want to dive in one of these projects, but I would say they are not complex enough. They are too simple to show what's really interesting. And the interesting part is, how do I structure an application which really has multiple screens and asynchronous I/O and so on. So I would say it's not such an app in this definition. So of course it's a very simple application with model view binding, but most of the applications which are done are far more complex, I think. So yeah, you might choose Backbone as a basis for your JavaScript application. Yeah, but you have to bear in mind it's just the beginning. You have to write an abstraction layer upon Backbone, and of course you have to find a solution that you don't have to write all the code yourself. So don't reinvent the wheel. And fortunately, you can stand on the shoulders of giants. In this case, the shoulders of GitHub. There are interesting and very mature projects, I think, which build upon Backbone. So most of them are, I would say, plugins for Backbone, but others are frameworks. For example, Thorax from Walmart Labs. They have built, I think, a huge mobile application on top of Backbone, and they have released their code as open source. Another frameworkish library on top of Backbone is Marionette from Derek Bailey, and there are others which are quite interesting, like the layout manager to deal easily with many views and nest views and so on. So today I will talk about Chaplin in particular. Chaplin is a project which we released on Friday. The context is a real-world project which is called, I think it will not work on this small computer. Okay. Yeah, the context is moviepilot.com, which is a site we built during the last year. It's a single-page JavaScript application using Backbone, and Chaplin is basically the core and the architecture of this application, and we really generalized that and released it as open source on GitHub. And I don't want to promote Chaplin here, but I will answer the questions you will face with our own answers we choose in Chaplin. So, oh yeah, I also said that it's not a library like Thorax or Marionette. It's more an example architecture. We want to document our approach we used in a huge Backbone application. So, sorry. So in the next couple of slides, I will present you the questions which we ask ourselves when developing moviepilot.com, and I will answer them with the approaches we have chosen. So the first question was, if the code grows, how to do not repeat yourself. So if you could either write much code based on Backbone, but we chose to extend the core classes of Backbone. So we have our own model, our own view, and our own collection. So this is basically done with prototypal inheritance in JavaScript. Yeah, and by the way, for moviepilot.com we have chosen, and for Chaplin as well, we have chosen CoffeeScript, so everything is written in CoffeeScript, and we're using the CoffeeScript class hierarchies and supercalls extensively to to write clean code in this case. And for example, I will show some classes here. For example, some models. I will just open some of these. Yeah, this is a good example. Okay. Oops, wrong. Sorry. Oh, now it's gone. I have to reopen it again. So the movie model, for example. Yeah, this is okay. This is a CoffeeScript class. So we have pseudo class declarations there. We can just say class movie extends full page, and full page is another super type. Yeah, and then we declare the methods there. So the code is very readable, I would say, and CoffeeScript might help you there. And of course, as you see, there are these super calls, so it looks like you're writing a class-based language, but of course you're not. It's prototype-based in the under the hood, so it all compiles to plain JavaScript. CoffeeScript just creates a little helper for prototypal inheritance. So yeah, it's basically an easy solution how to build a hierarchy of models and views, so you can reuse your own code. Of course, there you could choose any other approach. Yeah, you don't have to use this approach when it comes to inheritance and supercalls. Okay. Yeah, and in addition to subclassing the backbone classes, we implemented our some helper classes like the collection view, for example. So in Backbone, it's there's no standard solution how to render lists intelligently. So we wrote a collection view for that, which basically does everything automatically. You just put something in the collection, and the view is automatically adopted to that. Oops. Yeah, we already talked about scalability and loose coupling. Stefan talked about dependency injection, which is the term from the, I would say, JavaScript world. In JavaScript itself, it's a bit different. The dependency injection term, I think, isn't used so often, but basically the same is we basically found that there are solutions for that which just have another name, and one of these solutions is require.js, which relies upon a standard, or more or less standard, asynchronous module definition, also by the common.js group, I think. Yeah, we're using require.js for all dependency stuff, and also one of the bonus points of require.js is that everything is encapsulated, so you don't need global variables. You just declare your the dependencies of one file, and require.js handles the rest. So it automatically fetches the file from the server. Of course, you can pre-compile everything. So I will show an example. Yeah, here, for example, this is very simple. We define in this case, this is navigation.coffee, which is the model. A model extends the model class, so we declare a dependency. We want to load model and give it the local name model. So, and this function is called when model, the base class is loaded, and then we might access to it there. So another example, and this is more complex, I think. No, it isn't. Yeah, okay. In this case, the mediator is included, and the utilities are included. So you just, yeah, this is require.js. You define you define a module and can declare the dependencies of the model, and require.js will load them and pass them as local variables, so you don't have to write global objects and methods and so on. Yeah. So how to decouple modules after you have declared them? The answer we found so far, we're using a mediator object, so modules cannot and do not directly communicate with each other. They have to use a mediator between them, and technically it's not possible that they access the instances of other classes. So what they can do is they load the mediator, and here you can see this application view loads the mediator object, and then using this mediator pattern, it can talk to other modules. Specifically we're using the publish subscribe pattern. I don't know if you already know that. It's quite common. It means using the mediator object, you can just send some notifications. You can send messages. For example, if the user logs in, then you can send a notification login with the user as payload, and several other modules which you don't have to know about can listen to that to that message. So you can, on the one hand, you can publish, and there can be a lot of subscribers, and the publisher doesn't have to know which one is subscribing to the specific message. So the publish subscribe pattern is very important in our architecture for to decouple modules while ensuring that they can communicate with each other. Yeah, as I said, Backbone has routers, and a router, you can declare a URL which is then mapped to a method of the router. I didn't show an example there because we choose a totally different approach. When your application grows, you do not want to have routers which have the roots, so which are the URLs. Like for example, in Rails, there is this routes.rb file, and this to compare that in Backbone, in vanilla Backbone, you would have your roots in your controllers, and in my opinion, you don't want to do that. If your application grows, you want to separate these tasks. So we did that, and we are not using the router from Backbone, but wrote our own, and of course we published that code. Our router just does one thing. It maps URLs to some controllers and controller actions in particular, like in Rails. I will show an example. So these are for example, this is the router of moviepilot.com, and at the moment there's just this register routes method, which here you have some root, some URL, and this is the controller which will handle that. But better to show this one. In our generalized structure, we have done it like Rails does it, for example. So you match URL to a controller action. So match posts to the post controller and specifically the index action. So this is the way where we want to go. As I said, there are no controllers in Backbone. There are just routers. So what we have done, we have reintroduced controllers. because you need some kind of place where you instantiate models and views. And in our opinion, this is not the router itself, but these are controllers. This is more common in the MVC world. For example, in Rails, you would do the same. So, and in our model, a controller is responsible for one screen of the solution. So it creates the models and the views which are seen and you can interact with on one screen of the application. So yeah, basically how to bundle the code for a specific screen. Our answer is separate routers and controllers, so introduce controllers. Yeah, another question which Backbone does not directly deal with is how to manage top-level state. You have to build your own superstructure to manage the individual modules. So what we chose is an application controller. The application controller creates the models and views which are visible the whole time. For example, the header, the footer, or the user model, and so on. And between the actual router which just does routing and the controllers and the controller actions, we have put a component which is named application view. The purpose of this application view is to control the other controllers. So it's the controller. Yeah, it dispatches, so the router just says, okay, the route has matched, and the application view listens to that using pub/sub and knows the route has matched to this controller and this action, and the controller view is the component which starts the controller. So I think we will rename this because this is more like a dispatcher or so, but it's also a top level view which creates and removes controllers. So it really changes the DOM, and it shows the old controller. It hides the old controller and shows the new controller, and might do some transition between them. So yeah, we have the application view to manage the top level state. Yeah, and I think one interesting part is moviepilot.com is a site, is a single page application, and you might also log in on the client side. So we have some kind of persistency of user authentication on the server side, of course, but you can log in directly on the client side. This is possible with libraries from Facebook, Google, or Twitter. So most of the big players, the big identity providers, they also provide means to log in on an arbitrary site. So yeah, maybe I can demonstrate that. Okay, this is our totally simple and ugly example page for Chaplin. It basically has two features. It might display your likes on Facebook and the wall posts of the moviepilot.com Facebook site. Yeah, and in order to see them, you might log in on the client side, and this is done with the Facebook JavaScript SDK in this case. So you can just click on the login button, and yeah, then I'm logged in, and this data is loaded from the Facebook API, the graph, how's it called, Open Graph API. So this is just an example account. Yeah, this is on moviepilot.com. You might use several identity providers to log in. Currently, we support Google and Facebook, which support a client-side OAuth2 login. And there's also Twitter. You can log in with Twitter, but it's not a real OAuth client-side login. So you will need some kind of server-side component to deal with Twitter, because Twitter doesn't want to play OAuth 2.0. Yeah, but most of the other providers allow you to do the whole login stuff on the client. So, and as I said, all this data comes from Facebook. So we're talking with an external API and over the Facebook JavaScript SDK. Here another example, loading the wall post of moviepilot.com, and then I can also click here and I get redirected to moviepilot.com. No thanks. Yeah, this is the article which I have clicked so far. Okay. Yep. So yeah, in our architecture there's a component which is called session controller, which is responsible for the user management and login, logout process. And it's, as I said, it's encapsulated. You don't talk to it directly. You can send messages to it with a pub/sub, and it's a message emitter. So the login process is basically driven with events like login and logout. And these exclamation mark, you might trigger a login with these events, or trigger a logout. Yeah, and the session controller also is responsible to show login dialogues like this one on the right side here. This is a view which is created by the session controller. Yeah, so user management and user authentication is, I think, an interesting and important topic in client-side JavaScript applications today. So because yeah, you might shift the whole user authentication process to the client if you use OAuth 2 providers with a good JavaScript SDK. So everything can be done client-side if you want that. Of course, on moviepilot.com we save we authenticate on the server, because the server has to process some data and so on. It's not totally client-side, but what I wanted to say, you don't have to leave your application or you don't have to show a big login dialog. You can do it while you're in your single-page application. So I can log in and log out, so I don't have to leave the application in this case. Yeah. Okay, I think I have 2 questions left. Another important topic is how to deal with memory. I think most JavaScript developers are not familiar with dealing with these questions, because they rely on the garbage collector of the JavaScript engine to free the memory and so on. But when you're creating a huge single-page application in JavaScript, you have to, which is modular and MVC based, you have to think about this topic. Because there are some libraries which try to handle that, but in Backbone you have to do it yourself. So like for example in other class-based languages, you need some kind of destructor. So if a controller and its view and its models are disposed, you have to do this manually. And in our case, we just wrote a destructor method for every object we have created. So yeah, in Chaplin it's called dispose. For example, I have our this is the base model class, and this is the dispose method of the base view class. So you don't have to, we did this because you don't have to do this in all of your models. Most here is done automatically, and the key point in there is if you dispose a view, you have to remove all references to the view and its methods. And this is important because when you do a model view binding and publish subscribe, this is always done with references to methods. And the methods of views in the most of the time they are bound to the view itself. So if you do not remove this callback reference, the view cannot be garbage collected. So what we are doing here is we unbind all model handlers, unbind handlers of global publish subscribe events, remove the element from DOM, delete some properties, mark the object as disposed, and eventually we freeze the object so you cannot get or set everything on that. And you will get an error message, an exception when you try to do that. So you know this is a model which is disposed and you cannot use it any longer. So yeah, this is an example what we have done in Chaplin, and the model also has, this is the correspondent dispose method for a model. It looks basically the same. And of course, controllers also may be disposed. So yeah, this is the whole destructor stuff we have built. Yeah, and so we do not want to think about object disposal and memory leaks when we are writing the application. So that's why we wrote these core classes that have standard dispose methods which mostly handle the normal cases. So yeah, once you have this abstraction, it's a bit better with memory leaks, but you have to think about memory consumption, I would say, the whole time, because for example, in Internet Explorer and older Internet Explorers, the garbage collector isn't so clever. So yeah, you will have a look on that when you're developing. So yeah, I think the last question is how to handle asynchronous dependencies. I said there's a lot of asynchronous I/O going on a big site like a Movie Pilot, for example. We have here Facebook comments and so on, and yeah, we're lazy loading most of the data. So when the application starts, there are like 5 asynchronous, oh that's too fast. There are, in the background there are 5 asynchronous calls to several APIs like Facebook, for example, or get me my subscription, or the first is am I logged in, and so on. And the different modules have to wait for that. And the question is, how did we handle that? I will log in with Facebook. So, okay, yeah, Facebook. I will just go on. So these are the techniques which we have used to handle dependencies. The first is, of course, Backbone's own event handling. As I said, this events mixed in is very powerful. It's mixed into model views, routers, history, and so on. Then, of course, publish subscribe is the most important, I think, to handle with asynchronous dependencies, because you just have to, for example, if you've got a module which is interested in the user login, you don't access the user directly, you just subscribe to the login event or the out event and then react upon that. Another very interesting part is we have used jQuery deferreds. I think Jörn has also talked about them. yeah, we are mixing deferreds in most of our collections and models, which means they have a loaded state. They are either they have a pending state or a resolved state, and with jQuery with the deferreds, it's very easy to express dependency in your code very in a readable manner. So yeah, probably I can show an example here. I will try this one. Yeah, okay, that's a good example. For this is the login view, and in our example we're just using Facebook, but in theory it's open to provide several service providers. So in this case, we might have, like in on moviepilot.com, we have this screen where you can choose your service provider. So this is basically the code for that. You have a number of service providers, and the login view creates creates button for all of them. And what we're doing here is we are loading the JavaScript SDKs asynchronously. So we do not load the Google library unless you really click on login. And in this case, you can see Google doesn't load. Okay, there's the loading screen. So yeah, and the service provider is an example for I will open that. Here we just mix in a deferred in the service provider instance, and we also say defer these methods. So I can say I can call trigger login or get login status even if the service provider SDK isn't loaded yet. So yeah, these are examples of how we use deferreds. And on this side, I can just register a handler when the service provider is loaded. Then call the loaded methods, which in this case is service provider loaded, curried with the name and the instance. So, and in the other case, when the service provider fails to load, the button should be grayed out and disabled, which doesn't happen in this case, I think. Yeah, these are the deferreds, and I've also shown the function wrappers, and which we have used to work with deferreds in a more easier way. So because you don't have to wait until a deferred is resolved. You can just call its methods, and they are wrapped, so you can call them at any time, and the actual method call is then deferred until the deferred is resolved. So like in the service provider example. Yeah, I think that's basically all. So my name is Molly on Twitter and GitHub. This is my email address, and of course you can look into the code of Chaplin on GitHub. As I said, it's okay, yeah, I don't have a connection here, I think. So yeah, the code is I will edit here. So yeah, this is the repository on GitHub with the generalized structure, which has most of the stuff I have talked about today. Yeah, okay. Do you have some questions or additions? Yeah.
Where you have the main architecture diagram, there is database on the bottom. There is no application server or anything like that.
You can have some, yes, but
And
you
for
can.
example, in the movie pilot, do you?
On Movie Pilot, yeah, we have there are several Rails applications on the server. The API is a Rails application, which talks to a graph database over a REST interface. So in theory, we could talk directly with our Neo4j graph database because it has a REST interface. So yeah, you're right. Most of the time, you would have some kind of. I have written database there because you don't have database doesn't mean it has to be a server component, because you can use client-side storage facilities. You can use session storage or web SQL or IndexedDB and so on. That's why I just said data storage, something where you store your data. Might be on the client, might be on the server, and on the server you might have an application server or a database which directly allows you to communicate with HTTP REST. So yeah, you're right.
When you do something a little more complicated like this, do you have a model or something to hold all the metadata or the structure of the business classes?
What do you mean in particular, a model?
I don't know, UML or something like a.
No, because I think at the moment it's quite simple. So we just extended and augmented the base classes of Backbone. So there's model view and collection and
The business classes, like there's, I don't know, movie.
Yeah.
He has 3 attributes, and then something else has some other attributes.
Yeah, there are very complex hierarchies, but we didn't write them down formally. So there's, for example, we have topics, we have pages, which is a topic, and movies, which is a page, and series, which is also technically a page, but also a topic, and so on and so on. But it's not. It's more. Yeah, it's not a real entity model. So it's not a semantic structure. It's more how we build the front end. So a page is not a movie is a page. It doesn't make sense. But on moviepilot.com it makes sense. So yeah, page is just I would say a view model. So most of the time you have view models on the client because you don't yeah. You want to show some data. We want to build a UI and ask the server for the right data for it. So most of the time, your models are not semantic models; they are just view models. So
how do you synchronize changes across the layers?
Across what?
Across the layers, like there's some data in the database, and then you decide you will add a author or I don't know something.
Backbone already provides a strong mechanism for that. So there is syncing. You can fetch models from the server, and you have a fetch method and a save method, and you can override a sync method to implement your own syncing mechanism. Or you didn't mean that, sorry.
Like I add a column to the database, so I should adapt the code on the client to, or the other way around. Do you have like
okay.
deal with these changes?
Yeah, basically we don't have a formalized process for that. We have some kinds of document where the API structure is documented. So basically some kind of JSON schema, and then we have to adapt the server side and the client side, and yeah. So there's no golden path or golden way for that, I think. No automatic way, because we want to render new information, for example, in an article. Yeah, then we have to write it manually into the template in this case.
I've disabled JavaScript on Movie Pilot. There's no content scan.
Yeah, right. It's a single-page application, so we have just said what we want to provide we cannot do this without JavaScript. So if you have, for example, a desktop browser without JavaScript, we just say, okay, then you cannot use it because we want to provide you a rich user interface. But nonetheless, it's a very conventional application. So you have normal URLs. Every URL is accessible, at least for search engines. But you won't get the whole information if you're a desktop browser with disabled JavaScript. So you will, for example, a search engine can normally crawl the whole site, but there's no alternative for non-JavaScript users, which doesn't mean you cannot do this. We just
Google comes on your website with JavaScript, yes?
No. Without. There's a fallback content in the HTML. So Google gets the basic information from the HTML, but you won't see that if you have JavaScript enabled.
Actually, you can tell Google that you have a JavaScript website, and you can redirect into some server that provides a snippet of the page. So it could be interesting. This is what we do with Node.js. So render the stuff for the client in JavaScript, and for Google we render everything on Node.js. We have the same code, and we just provide it to Google.
How about memory on the client? I was trying to click around and it went up to 105 megabytes. That's about something like Gmail. And do you try to minimize that?
Yeah, the problem is that most of the memory isn't consumed by your JavaScript application itself. So of course you have to try to minimize the objects you're using in your application at one moment. But I think most of the performance on the page is more like complexity of the DOM, CSS, CSS3 effects, and images. So most of the memory is consumed by, and most of the performance, is consumed by these three components, I think. So we're not directly minimizing the memory footprint of the application, only indirectly using this whole destructor and disposal stuff. So this is just necessary so to prevent memory leaks. Okay.
Sorry to interrupt, but we have to stop now. We're already 20 minutes over time.
Okay.
I would like to thank Matthias for his demonstration.